Good morning, everyone. My name is Angad Sharma, and today we'll be learning a bit about wireshark. So, wireshark is basically a tool for network engineers and developers to actually see and visualize all of the TCP, UDP, ARP network calls, broadcast calls, visualize the packets, where the calls were made to, from where did they happen, how much packets were sent, and was it DNS enabled or not, SSL enabled or not. So basically, this is really useful in the case for like ethical hacking, where you need to see where are the vulnerabilities in your network, and then you need to really visualize how many ports are open, or you need to trace a call from or to a socket to a port, and then you need to really trace it from proxy to proxy, see where it goes, how much data was transferred, so that you can see that was your system hacked or not, where did the connection come from, and all of the details you can scan. And there is also a lot of options for you to actually TCP dump all of your data and then upload it later for visualization as well. So Wireshark works really well with all of the operating systems. It's a multi-platform tool, and today I'll be showing you basic functionality of Wireshark in Ubuntu 16.04 LTS. So this is the Wireshark's website. You can go there and download your version of Wireshark. So right now we'll be diving straight into Wireshark and its functionalities, and then we're gonna test on connection. So I am using Ubuntu 16.04 LTS. So you can you can do is to run Wireshark, you can do sudo wireshark, which sudo means a super user. It starts Wireshark in admin mode. It will ask you for your password. Wait for 1 second. Yeah, so Wireshark is on right now. So this is the file menu. Here you can export all of your packet dissections, import hex dumps from your TCP dumps and all. And here are a lot of functionalities. You can actually analyze your network, follow all of your TCP UDP calls, and so we'll be start capturing packets. So what exactly is happening here is that from every interface on my device, it's checking where the packets are coming from, where the packets are going, what is the data that's being sent. So this data is in the form of binary or hex, so it's scanning continuously. So, and what do I mean by network interfaces? By network interfaces I mean this. So if you do this, you'll get a list of your network interfaces, which are basically like a port, like an outsourcing port. So these network interfaces have their own ports and their own addresses. So there might be Ethernet or wireless. So let's say we stop it, we analyze one packet. So if you open it, you can see all of the data, all of the frames. The interface that was used here was WLP0S0, this thing, which is here. So if you want the information about your current port, you can do this. Yeah. So yeah, coming back to Wireshark. So let's create a connection of our own and actually visualize and trace it. So for creating a connection of our own, what I'll be using is the nc command. nc -l means listen on port 3000, and then -6 means that I'll be restricting it to IPv6, which is the IP address version 6. So now it's listening on localhost 3000. I'll just quickly curl into it. It got a get call, and I can say hello world over here, and hi, this is a bi-directional stream. It's actually getting the data over here. So let's actually sniff for the connections and try to capture it. So hi there, my name is Angad. So quickly stop it, and then since we restricted to IPv6, we'll be looking for IPv6 calls. So here we saw there is one IPv6 call. Quickly open it. We can see that the interface was this. So quickly stopping my connection, I can see I can do ifconfig grep.wlp. This was my interface, and then I can really visualize so how many frames are sent and what kind of connection it was. So this is the IPv6 address, and then Internet Protocol version. IPv6 address is a 128-bit address. So this protocol version was payload length, ICMPv6, the header, and the hop limit. Hop limit is the routing limit, and the source and the destination. And this is the data that I've sent. So like coming back to it, one more thing that we can do is we can right click here, or actually we can select this and we can go on analyze, follow, and we can follow all of these streams. So right now it's not sniffing. Let's say we start a sniffing session. Select anyone. I have selected a UDP connection over here. I go to analyze and follow, and I can actually see the UDP stream, live stream, all of the data that's been sent, the stream limit, everything. So this is a really cool thing when it comes to network security, and a lot of network engineers actually use this. So and there are a lot of things that you can do with this. You can analyze VoIP calls. So let's say VoIP stands for Voice over Internet Protocol, where you actually try to establish a voice connection between two interfaces. For example, a WhatsApp video call. So a WhatsApp video call uses VoIP. It establishes that connection, and then you can actually visualize it on wireshark. And then really good thing about this that you can save all of these things, and you can save it to your desktop as anything, and then you will not lose it. Like later you can quickly import it on your system. So this was some basics about wireshark. We learned how to open wireshark, sniff for packets, then we created a IPv6 server of our own. We established a connection, and then we were able to view and visualize the connection streams and the data really easily. And then we selected a UDP port. We went on follow. We were able to follow all of the connections, all of the streams and the data that was going to it. We talked a bit about network interfaces and how ports are attached to those interfaces for communication, and how to scan a network interface. And so that is my time. Thank you.